All right, a reminder. Dot products.
This is the thing.
Dot product is, you get AB cosine theta. These are magnitudes, just numbers without the angles. Theta means what? Angle between them, right? A cross B is magnitude of A, magnitude of B, sine the angle between them, and... And what is that, Natalie? Oh, sorry, Schneider. RHR.
Right.
Right hand rule for direction. Right hand rule for direction. So if I have an A here and a B here, and I ask you A cross B, I would put my karate chopper on the A. I curl my fingers because I'm using my right hand. I'd have to be really oddly anatomized to do that. That's not a word. I made that up. So then I have to flip over my hand, karate chop the A again, turn my fingers. That works. Stick out my thumb. A cross B would have the direction of into the
rule? What's happening?
board.
What's going on? What is this? What did you just do?
Karate chop A, Walker.
Okay. Chopped.
Curl your fingers.
Curled.
Do they curl in the direction of B?
No.
No. Flip over your hand. Karate chop it again.
Okay.
Curl your fingers. Do that the right direction?
Yeah.
Stick out your thumb.
The paper.
Karate chop A again.
Fine.
Right hand rule.
Okay. Sure. Well, I hate my right hand. Yeah, I don't need that. Okay, fine. And then it pops up.
Pops up.
What about it?
Okay, which way your thumb pointed?
Down.
Down. Into the board is the direction of the vector.
What? This means nothing.
B cross
What
A.
is this is
B
actual
cross
garbage.
A.
Will, you can skip this episode. I don't know what's happening. This is
B cross
useless.
A.
Oh my god. What is this?
B cross A. Karate chop the B.
Sure, absolutely. Let's see that it
Curl
goes
your
in the
fingers.
paper.
Does it work?
Oh yeah, it works.
Stick out your thumb.
Look at that wild, wild west.
Out of the board.
Woohoo! It's crazy. Look at that. Our thumb points up when we use the hand that way. What does this mean? What is this? What's going on?
All right, so I have some for you to play with. Try number one.
Oh, we get to do something. A times B.
Music provided by the Art Room.
Yeah, we should turn on some physics music.
You don't think this physics music?
No. Come on.
Sounds like your dubstep.
No, it doesn't. Because first of all, it's much better. Second of all, it's way
It
better.
is much better than your
Third of
dubstep,
all-
but I didn't mean to
No,
say that. I
that's
thought you-
not true
I
at
thought
all.
you were category.
Dubstep is the best. Okay, wow.
You do some problem, you A cross B.
Yeah, I'm already done.
You already done?
Easy.
Okay, so A cross B is going to be equal to A, B, sine theta. So A is 30, B is 27, sine the angle between them, which in this case would be 40 degrees. Agreed?
When this happened, what is this?
Make sure your calculator's in degrees for this.
Oh, look at that path.
Mine is not, so better fix it.
Wow.
Okay, 30 times 27 times sine of 40, and I get a
Don't
lovely
use that.
521, whatever the units would be, and I don't have any
What?
units, so I'll leave that be.
What is this?
Wait, don't hold the right hands.
Oh,
I got 405, so that's what's that? How'd you get 527?
I just typed this in my calculator equals.
Well, you're wrong.
30, 27, 527, whatever the units are.
You're like, what is this giving? It's like, what?
I'll give you an example in just a second. Let's get the right answer first.
Why'd you get
A, B,
527?
A, B into the board.
I think it's supposed to be 520.7, not 527.
Is that right? Yeah. Oh, it is 527. Wow. I have 127 videos on. No, 251 videos on YouTube.
Yeah.
Clearly I know math.
Yeah. I think so.
Not everybody can have that many videos. Takes
Have you
talent.
seen that gender studies kid show? They go through all 53 genders for little kids. I'm not joking. It's hilarious.
It is a physics classroom. That sounds appropriate for no classrooms. Okay, AB. All right.
You should do
So-
a little kid.
Karate chop it. So we did the karate chop it. A didn't work. Put my hand over it. Karate chop. Curl my fingers into the thumb, into the board.
Yep.
Okay. So what does this mean? For example, what's a cross product? A typical cross product is torque. If this is my force and this is my radius, then my force cross radius is be in newtons. That'd be meters. It'd be Newton meters of torque, and I would be screwing it into the board rather than unscrewing it.
What?
Done.
What just happened? What are you saying?
Right.
I'm
It's actually going this way, in the board. It's always perpendicular to the first two. Always, always, always.
What? This is some random leap. Like, what's happening?
He asked for an example. I give an example.
Okay, all I know is, okay, what is the dot in between versus the cross? What is that?
Dot means in the same direction, right? That's going to be VC cosine of theta.
Ooh, mixing it up. I see.
Wait, for dot products, you have to use
Spicy.
Nope, because there's no direction. There's no direction.
This is actually-
So what's a dot product we're familiar with? Work. Work's a dot product. And what's the direction of work? It's energy. It doesn't have one. It just amount. So this could be newtons, meters, joules, and what's the direction? None. It's just I have energy.
Wait, what is this number again? What is this?
What?
What is this number? Torque?
Well, the first one was an example of torque. Second one's an example of work because I'm using a dot product. Use dot products for work. What is the angle between those two? 65, 25? No, yeah, 25.
35.
Is it 35? No, it'd be 25.
What's that? How roll this up?
25.
Oh, yeah.
So it would be 27
Yeah, because
times
it doesn't-
12
That's why.
times cosine of 25. And I get 313. And again, no direction on it because it's a dot product. And dot products never have directions. For example, work.
Obviously. 293 joules.
All right, officially, as of this moment, we have a quiz next class period.
No. Wait, what? How'd you get 313? What are your numbers?
I got
Fix your calculator. Are you in radians?
I got 293.
I got 293 too, Max. Oh, look at that.
27, 12. What numbers am I supposed to use? 27, 12. 27
27
times
12.
12 times
Cosine 25.
cosine 25. Oh, I have cosine 15. That's a small error.
This guy.
All right, that would be 294, obviously. Yes.
So on some things,
Uh-huh.
like, I don't know which one.
It's always the first one.
No, it doesn't matter. It's not a thing.
On a cross product, A cross D, A. D cross A, D.
That's not a
Whichever the
thing.
first one is.
What? Oh, it's 0. Wow, C is 0. I did not say
I
that.
got 0.
Yeah,
Yeah.
I got 0.
D.
D is how much is perpendicular? You get the exact same vectors. How much is
But it's
perpendicular?
D. D.
Is that what we're calculating?
Straight.
What
D
is
is
this
how
number?
much is perpendicular, right?
What is-
Because we use cross products for torque. Well, torque is how far perpendicular the angle, right? The more perpendicular the angle, the stronger my torque. If I try to push along the same arm as the direction of the wrench, I get nothing.
Wait, but no, that's not true. No.
Yes, that's absolutely
Because
true.
what? No, it's like one of those like.
Okay, have your parents teach you how to use a wrench. I
It's
got
like-
lots of wrench work I could use.
It's like one of those things. with
We'll
the-
straighten that out for
You know
you.
what? I don't understand. Okay, if there's some lever and it's like like this, right?
Yes.
And you push it. What is that? What you're saying?
Yes.
It's better to push it here. For some
Better
reason?
push it perpendicular than to push it in the same direction. If I've got a wrench like this, here's my butt, here's my bolt. Okay? If I pull the handle this way, I'm not turning the nut at all.
Yeah.
If I push it this way, I'm not turning the nut at all. What's the strongest position?
Yep.
Perpendicular. Cross product is multiplies that which is
This
perpendicular.
isn't. If it was like straight away, maybe, but it's like this.
Okay, I'm drawing it that way, but if I've got a radius here, now this would be a force in this direction, and it's on a handle that's in this direction, that's its radius, then I got some piece that's perpendicular. By the way, the piece that would be perpendicular would be this piece here, right?
Is this important?
Yes. And that piece there would be cosine because it's wrong side of it. So if I go like this, I want to know the piece is perpendicular, right? So I'd want this piece here. Walker?
Yeah.
I want this piece here, which would be the sine, which is why we use sine. If I push in the same direction, my angle between the two would be 0.
Okay. I don't get that at all. What? You're just saying if I push on.
Doesn't come up very often much in physics class. Really doesn't. Occasionally they'll throw something at you just to see if you're paying attention. But if I have this
Oh, that's stupid.
dot this, the answer would be what, Walker?
I don't know what. I'm trying to catch up.
I know. Three-dimensional.
Okay.
So I'd multiply the i's. 1 times 1 plus 2 times 0 plus 3 times 1. And I would get 1, 4. Look at my answer. No direction because it's a dot product, right? If I were to try to do a cross product, 1, 2, 3, cross 1, comma 0, comma 1, I would have to do this. I, J, K, 1, 2, 3, 101. 1, 2, 3, 101. You then just write the first 2 rows. Right? And then I go like this, right? So we go 2301 I hat plus 3111 J hat plus 1210 K hat. Cro-Magnon days.
Where? Oh,
I just do this lump with the I, this lump with the J, this lump with the K. And then I just go Zorro, the last one, to go 2 times 1 plus 3 times 0, I hat, plus 3 times 1 minus, there should be a minus on this. Didn't matter because it was 0, but I really should have a minus there, especially because they were showing an example. Plus 1 times 0 minus 2 times 1. K hat. Right? This minus this. And then this becomes 2 I hat plus 2 J hat minus 2 K hat.
is it 3.1 or 1.1?
3 times 1. Multiply 3 times 1 minus 1 times 1. Okay, this hardly ever comes out, but it's possible they could throw that at you. Now, real quickly, this has no direction. Where's the direction here? It's giving you the components, right? So it's saying 2 this way, 2 in the I direction, 2 in the J direction, and 2 in the K direction. So it's going from here into the board like that. Because negative. Into the negative K means the other direction, positive K means out of the board. Okay? That's how we do 3x3s. Hardly ever going to come up in this class. Every so often I'll throw that at you. Just keep